static or sa akin lang may static? Okay, so for today, now we are going to discuss other exogenous hazards. Again, for today, we are going to discuss other exogenous hazards. And actually, there are three exogenous hazards that we are going to discuss today. Number one, yung tinatawag natin coastal erosion. First, we will discuss coastal erosion. Second, we will have sinkhole formation and ground subsidence. And the third exogenous hazards that we are going to discuss today is anthropogenic and allogenic fires. No? And itong mga hazard na to, no, these are very common hazards that we can experience, no. Although yung sinkhole formation siguro marami na tayong mga mitigation procedures, no, to avoid sinkhole formation, but at least we will have a discussion on this phenomenon or on these hazards kasi it can happen to us. But coastal erosion is very common since lalo tayo, we are Metro Manila and we are in a coastal area. So this is a very common hazard to us, and also anthropogenic fire, no? And even allogenic fire, no? Kailangan natin yang maintindihan kasi these are possible hazards that can happen in the Philippines. Okay, so the first exogenous hazards that we are going to discuss today is what we call class as coastal erosion. So pag sinabi niyo class na coastal erosion, we are speaking here of a hazard or a phenomenon kung saan class na-erode, no? Na-erode yung ating coastal area. So Manila is an example of a coastal area. And there is a possibility na ma-erode, no, yung Manila due to coastal erosion. Although it will happen for a long period of time, pero possible magkaroon na tinatawag na coastal retreat. And because of this coastal retreat, no, due to coastal erosion, there is a chance na ma-erode yung Metro Manila by the wave action, no, ng bodies of water natin. So technically, when we are speaking of coastal erosion, it is actually a hazard where the coastal area is being worn out, no? It is being eroded, thus nagkakaroon tayo ng tinatawag nating class na coastal retreat. And this coastal retreat is possible due to the wave action of the bodies of water. So yun yung tinatawag nating coastal erosion. And on the picture right now, no, pinapakita dito, class, paano nagkaroon ng coastal retreat sa isang coastal area. So dati, no, they are saying that the headland is here in 1866, but over time, due to some wave action, it is moved, no? It is moved towards here. By 1971, nandito na yung nandito na yung cliff natin, no? From here going to here. So technically, nagkaroon ng coastal retreat dito, no? Nagkaroon tayo ng coastal retreat due to coastal erosion. And this is possible due to the eroding effect ng ating waters or ng waves ng ating bodies of water. So meron tayong mga processes na nangyayari sa coastal area. We have erosional processes that is happening in the coastal area. So meron tayong tatawag na attrition. So pag sinabi yung attrition class, ito yung process or erosional process kung saan yung mga materials sa water, they bump to each other, causing them to break apart. So when we are speaking of attrition, this is a process where, again pag sinabi na attrition, this is a process where yung mga materials sa water natin, they are bumping to each other, and this collision of materials in water causes the weathering of the material or yung pag-break ng material into smaller pieces. So that is attrition. And usually, ang attrition nagre-result siya sa smoothed, no? Nag-i-smoothed yung yung mga rock particles natin in water due to attrition. Another erosional processes that we need to consider would be what we call as hydraulic action. Okay, let me show you a picture here, no, that can show you hydraulic action. So usually class, dun sa mga rocks natin along coastal area, may mga fractures yan. There are fractures. Tulad nito, if you would observe here, may mga fractures, no? There are fractures here present in the rocks, no, along the coastal area. So nangyayari, yung mga fracture na yan, meron yung air spaces sa loob. And once na nagkaroon tayo ng wave action, sometimes the air can be compressed inside this fracture. So, pwede siya makompress due to the entry of water or entry of waves through the fracture. So, isipin nyo, meron yang air, no? And this air is being compressed once na pumasok yung water along wave action here in this fracture. Ngayon, after compression, so napakataas ng pressure, and once this was released, kasi di ba remember na yung wave natin, no? Yung wave natin, nagbabak yan. Once na nagback yung wave, yung removal ng water causes again the re-expansion of the air, no, inside the fracture. And this re-expansion can cause explosion. Pwede siyang mag-cause ng explosion nung ating rock, no, nung ating rock body along the coastal area. And ito yung kadalasan na dahilan bakit tayo nagkakaroon ng massive erosion along coastal area. It's actually the reason bakit tayo nagkakaroon ng arc, ng stamp, ng mga cave. I will show you later, no? Paano yung progression ng mga natin, erosional landform natin along coastal rocks, no, which is actually due to hydraulic action. So technically, pag sinabi natin hydraulic action, yung alternate compression and expansion of air inside this fracture due to the entry of water would cause explosion, and this explosion causes the rocks to erode along the coastal rocks. So yun yung tinatawag natin class na hydraulic action. Meron din naman tayo class na tawag na corrosion, and corrosion is less mechanical, it is more on chemical, no? So yung water kasi natin may mga chemicals na present dyan, and the chemicals present in water can actually cause dissolution of rocks. So yung chemical action nung substances natin or chemicals in water can cause the dissolution of rocks along coastal area. Specifically, yung limestone and chalk. Limestone and chalk are very soft rocks. Napakalambot ng rocks na and because they are very soft, they are very prone to chemical action. They are very prone to this what we call as corrosion. And last class, the last thing that we need to consider, yung tinatawag natin abrasion. Okay, when you hear abrasion, class, ibig sabihin lang yan, yung mga particles na dinadala ng water nyo, it can cause the breaking of the parent rock. So for example, if you would observe here in this picture, meron tayong mga rocks, no? There are rocks along the water. So itong mga rocks na to, pwede siyang dalhin ng wave dito sa parent rock. And the bumping of these particulate rocks, no, that is brought by the water to the parent rock can cause the weathering or the breaking of the parent rock. So tawag dun sa process na yun is abrasion. Nangyayari din to even by wind, no? Wind can happen by abrasion, no? Pero here in coastal erosion, we will consider the abrasion, no, or yung process kung saan yung particulate rock sa water, it can cause erosion to the parent coastal rock in the area. So yun yung mga I think those are the 4 processes that is important for us to understand, no? At ito yung nagko-cause ng coastal erosion along coastal area. So we have attrition, no? And attrition is the bumping or the collision of the particulate rocks in water, causing it to smoothen out or to break into smaller pieces. Yung hydraulic action naman, it causes the alternating contraction and expansion of air, no, inside the rock fracture, causing the rock fracture, no, to causing the rock fracture, no, to cause breakage along the parent coastal rock, no, in your coastal area. So that is hydraulic action. Corrosion naman is more on chemical reaction or dissolution of the parent rock due to the substances present in water. And pag sinabi niyo naman abrasion, ito yung pag-erode by the use or by the bumping of the particulate rock from water to the parent coastal rock. So tawag doon is abrasion or corrosion. So ngayon, bakit ba tayo nagkakaroon ng coastal erosion. And ano yung dynamics niya? So, coastal erosion is due to those four processes, no, that I have described to you kanina. It's due to attrition, due to hydraulic action, corrosion, and poration, o yung tatawag natin abrasion. Pero yung dynamics niya, class, kasi ganito, usually kasi along the coastal area, hindi homogeneous yung coastal rocks natin. May mga area na kino-consider tayo as hard rock, may mga area tayo na kino-consider as soft rock. So palagay niya, sinong unang mag-erode sa kanila? Is it hard rock or soft rock? Usually itong soft rock na to, it's made up of limestone and chalk, no? Kadalasan yung mga soft rock na yan, it's made of limestone and chalk. And based on your understanding so far, ano kayang unang mag-erode? Is it the hard rock or the soft rock? Sige, David.
Kasi gawa siya sa limestone and chalk.
So it's easier to erode. So nangyayari, nagkakaroon tayo ng discordant structure. So tulad nito, pinapakita ko sa inyo, di ba? If you would observe here, dito eroded, this is easier to erode than this one. So this would take a shorter period of time to erode yung soft rock, no, kaysa sa hard rock. Because of that, we are producing discordant structures. And makikita niyo yan pag may mga cliffs. Ayan, this is an example of a cliff, no? At tong cliff na to, it's actually a discordant structure. It's a remnant of a hard rock, no? Hard rock to, class, that is harder to erode compared to its adjacent soft rock. So kung mapapansin nyo, this area is a soft rock. It's easier to erode than this hard rock, yung headland natin o yung tinatawag nating cliff. So ayan, yung mga cliff or headland na yan, these are comprised of hard rock, which is harder to erode, and sandwich or adjacent to this hard rock are soft rocks, no? And that is why kung nasa nasa beaches kayo, no, nasa dagat kayo, mapapansin ninyo na usually may headland or may cliff, no, cliff dun sa dalawang sides ng beach. It's due to the fact na meron tayong discordant structures along the coastal area due to the presence of different hardness ng rock. Tapos usually yung soft rock, pag na-erode sila, nagpo-form sila ng beach na tatawag, no, that is comprised of sandy soil, and the sandy soil are actually sediment that is eroded, no, in the soft rock. So we would expect na byproduct siya ng erosion ng chalk or limestone, yung sand natin. So another things na nakikita niyo dito, no, itong formation na to, kung saan meron tayong, this is I think a convex ba? Yeah. I think this is a convex, no. Tong convex na to, am I correct? Is this a convex or a concave? I forgot my shapes. Ano to, convex or concave? Kindly correct me on this. Is that convex or concave? Can someone? Ano yan? Is it a convex or a concave? I forgot them. I forgot my shape. Wait lang. Let me check. I forgot my convex and concave.
Unlike emperors said, rationally speaking,
Wait lang. Let me search. Yeah, it's concave pala. So ito, if you would observe, there is a concave there is a concave formation dito. It's due to the fact na this is harder rocks that has slow erosional rate compared here in the middle, which are comprised of soft rocks. And because of that, meron tayong nafubuong bay, no? And this bay is this structure, no, in between discordant rocks. Another thing that you need to consider is yung erosional process natin. It's able to produce your cave, your arc, your stock and stump. And let me show you how it is formed. So nag-umpisa tayo sa headland or cliff na tinatawag. Itong headland or cliff na to, once nag-start na siya mag-erode, syempre cracks muna. So after cracks, kung talagang nagkaroon na ng explosion, lalo na due to hydraulic action, there's formation of cave already. Yeah. So we have cave, then pwede tayo makabuo ng arc. From arc, we can form what we call as pillar. Then from pillar, we have stump, and drift. So sa reef, ilalim na lang yun. And pwede rin totally magka-coastal retreat. So nakita, so over time, no, this coastal rock can be eroded. Nagkakaroon tayo na tinatawag nating coastal retreat. And it cannot be avoided. Lalo-lalo na merong wave action tayo across waters. Anyway, this is the original photo where I took those different erosional landforms. Now, another thing that we need to consider is yung tinatawag nating longshore drift and longshore current. So, ganito, pag nagkakaroon ng current across the coastal area, pasigsag yung pattern niya. Sigsag yung direction niya. So, longshore current, directionality is in zigzag. Paano siya nagiging zigzag? Tignan nyo. Pa-diagonal siya pupunta sa coastal area. Then, pag magbabackswash siya, it is in a straight line. So, nangyayari, swash, backswash, swash, backswash, swash, backswash. So, nakaka-produce kayo ng diagonal swash, meaning diagonal incoming wave. Then, yung back wave mo, yung backswash na tinatawag natin is 90 degrees to the coastal area, producing a zigzag pattern. And, as a result, nagkakaroon tayo ng tinatawag na longshore drift. And pag sa longshore drift, yung yung pag-deposit natin ng sediment across your beaches, it is in a way na meron tayong pattern na nabubuo in a zigzag pattern. Ayan, if you would observe, zigzag yung pattern ng deposition natin ng sediments along the coastal area due to longshore current. Ang tawag dito is longshore drift. Ayan, due to zigzag pattern of swash and backswash, ang nagiging result ninyo is also zigzag accumulation of deposit along beaches. Kaya kapag napupunta kayo sa dagat, diba, napapansin ninyo, mataas, mababa, mataas, mababa. It's due to longshore drift. Natatawag natin yung pattern ng deposition natin ng materials. And the question is, how can we manage, paano natin mamamanage yung natin? How do we manage what we call this? How do we manage our coastal erosion? So let me show you a video that explains how to manage coastal erosion. Kasi kung imagine niyo, medyo mahirap mag-manage ng coastal area for a while.
Now let's use the brain. Predictably, processes external inputs, of course, the brain is functions as the one which processes plus external inputs and internal subjective experience consisting of the experience of the body, that according to step 15, and on consciousness
for a while, class.
On these spaces. Right? Our conscious experience of the world, therefore, is largely a prediction of what is about to happen next, or more accurately, what the next inputs are likely to, according to Clark, 2016, and Schultz, 1970. Okay, the brain. Now, these one, the self-class, okay, traits that define a person and then the description. So we have this one, the self-awareness, a person having a clear perception of oneself, including his or her thoughts, emotions, identity, and action. Okay, so a clear perception of oneself. You have self-awareness. Okay, and how about self-determination? This refers to capability of persons, this one class. Capability of persons to make choices and decisions based on their own preferences, monitor and regulate their actions, and goal-oriented in self-development. So you will call yourself often have a
Okay.
self-determination.
So, klase, yung pinapakita sa video na yan, ano yung mga possible structures, no, na itayo natin? Ano yung mga possible engineering structures na pwede natin itayo along coastal area so that we can manage coastal erosion. So, kindly watch the video. Okay, naintindihan niyo seawall class.
Constructed in relation to
May question kayo about
sources
seawall.
and structures and the product of ongoing negotiations.
Sir,
Yes.
yung nasa Manila Bay ba is kan po ba yun? Example rin po ba yun?
Yes, coastal erosion management, ano yun, structure yun. Pero that is not a seawall, hindi siya seawall. Iba yung ginamit sa Manila Bay. Siguro you will see that later on. Okay, can we continue? Naintindihan niyo seawall, ah? Let's proceed.
Number one, so that we will
Sir, di po
We
naririnig.
learn
Yes.
Di po.
Hindi naririnig?
Di po.
Wala kayong audio na naririnig?
Wala po.
Hindi kayo nagsasalita.
Kala ko sir, nagkakan lang ka dito, parang nag-loading.
Bakit walang audio? Okay. So, ito na lang. Let me discuss to you, no. Meron tayong mga engineering strategies na pwedeng gamitin if we are speaking of coastal management, no, coastal erosion management. So, meron tayo class tinatawag na hard engineering saka soft engineering. So, we have what we call class as hard engineering method saka soft engineering method. So, anong pagkakaiba ng hard engineering sa soft engineering? Sa hard engineering methods, no, gumagamit tayo ng mga artificial barriers tulad ng mga pinapakita sa inyo kanina. So example ng mga artificial barrier, no, will be the seawall. Yung seawall pinakita kanina sa video, revetments, rock breakwater, riprap, no. So those are example of hard engineering methods or hard engineering techniques that you can use for coastal erosion management. So tatandaan niyo, pag hard engineering yung methodology natin, it's more on artificial barrier. Meron din naman tayong tatawag na soft engineering. So sa soft engineering, instead of using artificial barrier, gagamit tayo ng natural environment, no? Yung natural environment along the coastal area to mitigate coastal erosion. So ito yung paggamit ng natural materials, no? So that there is mitigation for coastal erosion. Yun yung pagkakaiba ng dalawa. That's the difference between your hard engineering methods and soft engineering methods. I think class, I will not dwell too much with this kasi we need to proceed to sinkhole formation, no? Yung ground subsidence and sinkhole formation. So what you need to understand is sa coastal erosion management, pwede tayong gumamit ng dalawang approaches. We can use hard engineering techniques and we can also use soft engineering techniques. The thing is, meron naman akong video sa module where you can study that thoroughly, and you need to study that thoroughly kasi I have activities on hard engineering techniques and soft engineering techniques. So kindly watch that in your module in the RRR for this lesson. So I think that's all we have to discuss for coastal erosion. Before I proceed, may tanong pa ba sa coastal erosion? You have question on coastal erosion, class?
Wala po ako, sir.
Okay, so I think everything is clear about coastal erosion. Ganito na lang, class, yung coastal management kasi walang audio yung meet. You can watch it in the module. You need to study the different coastal erosion management techniques. And there is a video in your module that details, no, ano yung iba't ibang klase ng hard engineering approaches and soft engineering approaches on coastal erosion management. So I think we are now done with coastal erosion. Let us proceed to the next exogenous hazard, which is ground subsidence and sinkhole formation. For a while. Okay, before we discuss sinkhole formation, I think we need first to understand ano ba yung karst environment. Kasi karst environment plus yung ating sinkhole. Sinkhole is an example of a karst environment, and in order for you to understand what truly a sinkhole is, no, kailangan maintindihan natin ano ba yung karst environment. Anyways, you study this when you are in grade 11, no. Inaral niyo to, these are actually erosional landforms, no, yung mga karst environments natin. And yun nga, one example of this karst environment is yung tinatawag nating class na sinkhole. So let us begin, no, with ano nangyayari. Okay, let's begin with karst environment. So when we are speaking of karst environment, that's technically yung caves natin, no? ito yung caves natin, or these are actually land formations, no, that is formed by the desolvation of the parent rock. So technically, in a karst environment, there is a deformation of your parent rock, and this there is a desolvation, not deformation. Sorry for that. When we are speaking of karst environment, there is desolvation, meaning na dissolve, no? Na dissolve or nagkaroon ng chemical action on the parent rock causing it to dissolve. So it's either physical dissolution or chemical dissolution, and this dissolution of the parent rock produced a cavity in your parent rock, and tong cavity na to is usually in the form of caves. So pag narinig yung first environment, the first thing that will come into your minds are caves, because these are cavities, no, these are holes or cavities formed inside a parent rock. So to fully understand what is a karst environment, no, um, let me show you this. So this is an example of a parent rock kung saan we can observe here many karst landform. Ayan na, may mga karst landform tayo. So if you would observe here, wait lang for a while. So sorry for that. So let me go back here, no. Yun nga, yung parent rock natin dito, if you would observe, there are cavities formed, and these cavities form is due to the dissolution of rock. So nagkaroon tayo ng dissolution of rocks due to some physical and chemical action of water. No, and these cavities class form your caves and other karst landform. So usually, what happens is that due to water action, no, due to water action specifically, yung groundwater natin in our parent rock, nagkakaroon tayo ng desolvation of the parent rock. And this desolvation of the parent rock would cause the formation of cavities in the parent rock. And once na bumaba yung groundwater natin, kasi bumababa yung water table or groundwater natin, lalo na kung it is extracted, no? It is artificially extracted through artesian wells. So nangyayari, there is a possibility that caves would form, or yung mga karst environment natin would form up along your parent rock. So yan. So that's an expansion of your understanding on karst environment. And one of the secondary effect of formation of karst environment or caves is the formation of sinkhole. Later on, I will describe paano ba nabubuo tong sinkhole na to, no, and how is extraction of groundwater is very related to formation of your sinkholes. So what are example of karst environment? So of course we have the springs, no? This is an example of a karst environment kasi actually yung spring, it is actually a hole that is formed along the parent rock, and tong hole na to would cause the removal of groundwater from the parent rock. Remember, nasa parent rock natin, sometimes nag-infiltrate dyan yung water. And underneath the parent rock, meron dyan area na tinatawag nating water table where water can flow. Sometimes there will be a point na makakabuo tayo ng hole, mag-serve siya as exit point for that groundwater, and this exit point for groundwater is yung tinatawag nating class na spring. Meron din tayong tatawag na disappearing stream, so usually may flowing water, then after a few while mawawala siya. It's due to the fact na pumasok siya underneath, no? Masok siya underneath the parent rock due to a presence of a karst landform. Ito. So the best example of your karst environment is a cave. And usually sa cave, meron dyang mga calcite formation, no? Itong mga calcite formation includes the following. So itong nakikita niyo sa taas, this is called as the stalagmite. Ito naman nasa baba, these are stalactite, no? At itong mga to, itong stalagmite and stalactite na to, these are actually calcite deposits, no, ng dripping water sa cave natin.
And by means through instruction.
So the question is, bakit ba tayo nagkaka-caves? How do we form caves? So usually, yung mga caves natin, it is formed in a soft parent rock. No, nabubuo siya sa mga soft parent rock such as limestone and let us say limestone, chalk and calcite. So kung soft yung parent rock natin, there is a possibility na ma-dissolve siya ng groundwater. Remember that groundwater can infiltrate the parent rock. No? So yung water natin, let us say nagka-precipitation, nag-infiltrate siya and became a part of groundwater. Itong groundwater na to, there are chemical substances no, present there that can cause dissolution of rock. So most of the time, una, there is only a small cavity formed. So over time, lalaki siya na lalaki due to erosional processes no or chemical dissolution no chemical erosion or yung tinatawag natin dissolution of the parent rock usually by soft parent rock such as limestone and because of this no yung limestone and chalk natin and because of this lumalaki yung cavity na form inside the parent rock. Now may time kasi na bababa yung groundwater, yung water table na yun. Once na nag-lower yung water table due to, let us say, natural or artificial processes, ito yung time na makakabuo tayo ng cave kung saan instead of being filled with water, yung cave natin at this point is already filled with air. Ayan, so that's the initial initial process no why we form what we call as a cave, no? Ngayon, the thing is that doesn't end the evolution of the cave. So over time, let us say, na-filled na ng air yung cavity natin. Pero class, even though it is filled with air na, darating pa rin yung point na i-infiltrate yung parent rock ng water. So nangyayari, pwedeng mag-infiltrate yung water through the parent rock and mag-drip off dito sa natin. Mag-drip off dito sa cave natin. Nangyayari, meron kasi sometimes carbon dioxide yung water. And this carbon dioxide would react with the calcite of the limestone. So, with reacting calcite of the limestone, pwede tayong mag-deposit ng calcite sa taas, no? At mag-deposit ng calcite dito sa ilalim. So, yung calcite na nade-deposit sa taas, tinatawag siyang stalactites at yung calcite na nade-deposit sa ilalim, no, on the bottom of the cave, would be called as your stalagmite, no? The stalagmite and the stalactite. Okay, this is the stalactite. Sorry pala kanina nabaliktad ko. This is the stalactite and this is your stalagmite. Yung tatawag natin stalagmite. So yung upright, we call that as stalagmite. Yung naka-invert, we call them as stalactites. No? So yan. So for you to understand that further, ayan, yung dripping water natin, sasabi sa inyo, yung nag-infiltrate na water, yung nag-drip up sa cave natin. Yung carbon dioxide then would react with the calcite of the limestone rock. And upon reaction, na pwede mag-deposit dito sa taas, forming your stalactite, sa ilalim, forming your stalagmite. And pwede rin silang mag-connect. Once na-connected sila, they will be called as columns. We call these formations as columns. So this is an example of a cave, no? Cave. Ito na, air-filled cavity na siya. And if you would observe here, there is dripping water. Yung dripping water nito would later on can possibly form a stalactite and stalagmite. Remember that this would happen for a long period of time, no? Hindi yan mangyayari in an instant. This will occur for a long period of time. Anyways, this is your stalactite, stalagmite, and ito yung tatawag natin column connected yung stalactite and stalagmites natin. Ayan. Ito yung mga cave formations natin. Yan, may iba rin formations tulad ng helicites. So we call this as helicites. Chandeliers, flow stones, and flow stones, thin columns yan, flow stones. No? Yung cave bacon na tinatawag. At napakarami pa. There are actually many formations pa that can be found in a cave. So ito, technically, this is water-filled cave. No? This is not air-filled cave. So ngayon, the question is, bakit tayo nakakabuo ng sinkhole? So this is an example of a process. This is actually a transitional process from a plane going to a sinkhole. Wala pa tayong sinkhole by this time. No, nasa transitional process na yan. Possible na lulubog to over time. No, upon sinkhole formation. So why do we form sinkholes? So ganito nangyayari. So ayan, so what I'm showing you is yung process na sinasabi ko sa inyo kanina, pag-infiltrate ng water would form karst environment, no? Karst environment across the parent rock such as the cave, no? Lalo na kung nag-lower yung water table. Ngayon, the thing is ito. So by this point, no, meron tayong cave filled with water, no? Meron tayong cave filled with water. So over time kasi pwedeng bumaba yung water table natin. And this water table, sa pagbaba ng water table natin, marami yung profound effect. Ulitin ko So una meron tayong cave formation dito. So this cave formed due to the dissolution of your soft rock, your soft limestone by the carbon dioxide of water. Ngayon, sige, bago tayo mag-proceed doon. Kasi class, yung water natin, ang maganda kung yung inyong cave is filled with water, yung water magbibigay ng support or ng stability dun sa cave natin. Pero darating kasi yung point na talagang maglo-lower yung groundwater. So it can be lowered by two means. Pwedeng natural yung means ng pag-lower ng groundwater natin or pwede rin naman ang means nun would be artificial means, no? Pero tatandaan ninyo, itong water na to on your cave can provide stability to your cave. Ngayon, let us say nag-lower yung groundwater natin. No? Pag nag-lower yung groundwater natin, there is a greater chance na ma-erode. Ma-erode tong lupa along the sinkhole. No, along the cave. Hindi pa siya sinkhole. Along the cave. So pag nag-erode to, kasi nga nabawasan stability because of the removal of water, naging prone to sa erosion, and if there is a continuous erosion, continuous na mag-thin out yung lupa na to until such point na magko-collapse siya. And once nag-collapse na yung lupa, no, along the cavity, dun tayo nakakabuo ng tinatawag nating class na sinkhole. Ayan. Ayan, so yun nga, tulad ng sabi ko, there are many possible reasons bakit tayo magkaka-sinkhole. So number one, it can be due to natural causes. Pwedeng natural causes. Second, pwede siyang artificial causes. So let us look kung natural causes. So let us say ito yung natural causes natin. Let us say meron tayo ditong water. So meaning stable pa rin to. Pero although meron siyang water, there is a chance pa rin kasing ma-erode to, and with continuous erosion, pwedeng mag-collapse yung lupa. Pwede rin naman tayo in a case na naturally bumaba yung groundwater kasi let us say nagkaroon tayo ng spring, and pag nagkaroon tayo ng spring, ang result doon, mababawasan yung groundwater nyo, thus losing the stability of the cave, no? And upon that, pwedeng mag-erode yung lupa at magko-collapse siya. So those are the possible natural causes. Pag artificial naman, let me show you this. So dito, no, ang nangyari, rinetrieve nyo yung water, yung groundwater by artesian well. Kaya nga dangerous ang artesian well. Kung mapapansin nyo, 'di ba? Although it's sustainable water source, no, pinalitan siya over time. Hindi na tayo gumagamit ng artesian well ngayon. Kasi itong artesian well can promote the formation of sinkhole. Kasi tignan nyo to, upon extraction of groundwater, pwedeng mawala yung stability ng lupa, and tignan nyo, it can result to collapse if we remove too much water by artesian well. Pwede rin naman mangyari is magkaroon tayo ng overloading, magkaroon tayo ng surface loading, and with excessive surface loading on land, pwedeng mag-collapse yung lupa, causing sinkhole formation across the caves. So those are the possible routes to forming sinkhole. So this is an example of a sinkhole, no, due to either surface loading or extraction of water by artesian well. Okay, this is another example of sinkhole formation. And so I think so ayan yung artesian formation na yung pag-form ng artesian well. And sometimes maybe it's sustainable, but it can be dangerous, no? Also, medyo dangerous din siya Kasi nga, lumalaki yung population natin, lumalaki yung demand for water, and because of that, there's a chance to drain so much water from your underground sources, and ang possibility, maka-form tayo ng sinkhole. Okay, class, before we end our discussion on sinkhole, did you understand what is sinkhole and the sinkhole formation process? Naintindihan po ba?
Okay? And
Yes
Maliwanag?
po, sir. Po.
Okay. So far naiintindihan yung lesson, no? So we're done with coastal erosion, and we're done also with sinkholes, no, and ground subsidence. So the last thing that we are going to discuss, or the last exogenous hazard that we're going to discuss, is yung fire natin, yung allogenic fire and anthropogenic fire. Ito lang tatandaan ninyo, pag allogenic fire, when we are speaking of allogenic fire, it's natural fire, yung mga wildfires na tatawag natin. Pag anthropogenic, it's urban fire, usually created by artificial means, by human or any artificial means. So let us start our discussion with fire.
religious and a physical instinct.
For a while.
Meanwhile, the 19th century Englishman Herbert Spencer compared to organisms dependent
So, ganito, since we are going to talk about fire, no, allogenic and anthropogenic fire, the first thing that we need to understand is ano ba yung fire, ano yung behavior ng fire natin. So, tatandaan ninyo, class, fire is very important, no? It's important, but it can be also dangerous because it can impose hazard to, to the exposure. So, ano ba yung fire? Fire is actually a combustion reaction. So, it's an example of a chemical reaction. It's a combustion reaction that can happen at a slow rate or a very fast rate. So kung napakabilis ng fire natin or ng combustion reaction natin, tinatawag yun, class, na detonation. So when we are speaking of detonation, this is actually a combustion reaction or a fire that travels at the speed of sound. So ang bilis pala ng fire natin, pwede siyang umabot up to the speed of sound, and that is very dangerous. So tawag natin detonation. It can be also in the form of deflagration. And when we say deflagration, it is actually a rate of fire na napakabagal. It's slower than the speed of sound. Pero hindi siya totally slow. It's just slower than the speed of sound. So we wish na kung magkaroon man ng fire hazard, it's not detonation, but it's just deflagration. Pero still, it's very dangerous. So how do we form fire? In order for us to understand paano tayo nakakabuo ng fire, we must understand, class, yung tinatawag nating fire tetrahedron. So meron tayo, class, na tawag na fire tetrahedron, and in this diagram na pinapakita yung fire tetrahedron, and this fire tetrahedron is a diagram that can let us understand paano ba nakakabuo ng fire. So in a fire, no, scenario, hindi mo pwedeng mapaghiwalay itong apat na to. So there is always fuel, there is always heat, and there is always oxygen. And of course, this is a chain reaction. So, yung fuel natin, class, when we're speaking of fuel, these are materials, no, na pwedeng mag-ignite. So, lahat naman ng fire, it would start at ignition. It would start at ignition. And itong fuel na to, it can be in the form of solid, liquid, and gas. So, example of solid fuels will be wood, paper, and grease. Example of liquid fuel natin will be gasoline, turpentine, paint, and chemicals. An example of gaseous fuel would be natural gas, propane, and carbon monoxide. At napakarami po. Now, in order for this fuel to ignite, syempre, kailangan natin ng heat energy. At mapapadaliz tong chemical reaction na to with the use of a catalyst, which is oxygen. So technically, the three are non-separable. And remember that once na nag-umpisa yung fire, it's actually a series of reaction, or it is a chain reaction. That is why we consider this fire tetrahedron. Ngayon, dati kasi, ang view lang ng tao sa fire is tatlo. They only thought that there are only three components of fire, which is fuel, heat, and oxygen. No, kasi dati hindi pa nila nare-realize that fire is a series of a chemical reaction. But today, it's the other way around. They already have an understanding na there are apat, no? May apat tayong components for fire and its behavior. So it includes the fuel, no? The source of fire, the heat, the driving force of fire, the oxygen, the catalyst for fire, and yung succeeding chemical reaction once na nag-start na yung ating ignition. So let us examine, no, yung heat. So para kasi magkaroon ng fire, kailangan ma-ignite yung fuel. And how would you ignite the fuel? In order for you to ignite the fuel, kailangan mo ng heat energy. There must be some kind of heat energy so that mag-i-increase yung temperature. Remember that heat energy is the energy that would cause change in temperature. So magbabago lang yung temperature ng system ninyo once na merong heat energy. And in order for the fuel to ignite, kailangan tumaas yung temperature niya to a point na maaabot niya yung tawag nating flashover point. At pag sinabi niyo class of flashover point, ito yung point, no, kung saan nag-umpisa na mag-ignite yung fuel natin. And mangyari lang yun if there is heat energy enough to heat, no, the fuel to ignite. So, marami tayong possible sources of heat. Pwede siyang mechanical, no? It's produced by friction of two materials. Pwede electrical, pwede nuclear, pero usually ang urban fire hindi naman nuclear ang cause, kadalasan electrical or mechanical fire. Also chemical, no, chemical, mechanical, and electrical fire are the common causes of fire. Common causes of fire. So yun yung common causes ng fire o yung common heat source niya would be chemical heat, mechanical, or electrical heat. So ito pinapakita, upon friction, meron tayong heat production, no? So ito, upon the movement of charges, we can produce heat energy. Kaya nga pag nasobrahan yung resistance sa electrical wire natin, too much heat is produced and it can cause electrical fire, no? Due to heat production ng electrical wire natin. Kaya kayo, pag nakikita nyo na yung wires ninyo, medyo umiinit na, meaning it's generating too much heat, you need to turn off you need to unplug the electrical wire before there is too much electrical heat to be produced by the wire. So, another thing that we need to consider is fuel. Na-discuss ko na to kanina. Ano ba yung mga fuels natin? No, it can be solids, liquid, and gas. And these are the material that can cause combustion. Siya yung magiging cause ng combustion natin. So, it can be in the form of solid, liquid, and gas. And remember, the most effective fuel, no, ang pinaka-effective fuel natin would be gaseous fuel. Again, the most effective fuel amongst all would be gaseous fuel. So oxygen is also a very important part of fire or combustion reaction kasi siya yung catalyst, no? Siya yung magpapabilis ng combustion reaction natin. And with so much oxygen present in an area, no, ang possibility is that, no, mas mabilis or mas mapapabilis yung flame formation natin. So ayan, so if you have an oxygen-rich environment, thus the fire or the speed of fire would be greater kesa sa low oxygen environment natin. Another thing that we need to consider is that yung water, remember water is rich in oxygen. Thus, pag sinabuyan nyo ng tubig yung fire, it will not be a very effective means. Sometimes it can also trigger greater rate of spread ng fire natin. And yun nga, tulad ng sabi ko sa inyo, fire itself is a series of a chemical reaction. Now, pag nagkakaroon tayo ng fire, no, it's actually due to the fact na merong natatransfer na heat energy across the system. So sa bahay ninyo, pag meron natatransfer na heat energy across the system that would let the fuel ignite, doon tayo nagkakaroon ng fire. And the heat energy can be transferred in three ways, no? Pwede siyang matransfer by conduction. So, tatandaan niyo yung mga walls ninyo, specifically kung conductor yung wall ninyo, it can easily transport heat energy across the wall. Also, pwede rin through convection, yung is convection smoke natin. Yung convection smoke na yun, it can transfer heat energy, no? Heat energy across one area to another area. Kaya nga yung sunog, 'di ba? Pag nagkakasunog, mabilis siyang kumalat from one room to another kasi nangyayari yung convection smoke nyo, nagta-transfer siya from one region to another region of the house. And this transfer of convection smoke from one region to another region of the house causes the transfer of heat energy. And pag sobra-sobra na yung heat, no, darating yung flash over na tinatawag kung saan mag-aapoy rin yung fuel sa isang room. So kaya mabilis kumalat siya po from one room to another. It's due to convection heat na to, yung convection smoke na nagta-travel from one region to another. Now, di ba kayo nagtataka bakit pag merong fire, minsan nadamay yung mga katapat na bahay, isipin nyo magkaharap lang, pero pwedeng masunog yung katapat na bahay. It's actually due to the fact na aside from conduction and convection, meron din tayo radiation. So pwede tayong mag-radiate ng heat energy from one building to its adjacent building. And with too much heat energy transferred, pwede rin yun mag-cause ng flashover. And after this flashover, doon na tayo magkakaroon ng tinatawag nating fire. So fire is due nga to enough temperature to cause ignition or maabot yung tinatawag nating flashover temperature ng fuel. And it's possible talaga kasi there are many mechanisms where we can transfer heat energy. We can transfer heat energy by conduction, we can transfer heat energy by convection, and we can even transfer heat energy by radiation. So, ayan. And usually, class, what makes fire dangerous, no? Kasi marami siyang byproduct. Example would be the following byproducts of fire. We have carbon monoxide, hydrogen chloride, benzene, soot, no, oil or tar, and hydrogen cyanide. And these are very dangerous. Kaya kapag nasa vicinity kayo ng fire, medyo dangerous because there are too many byproducts that is produced by fire. So now let us begin to discuss yung dalawang klase ng fire natin, no, that can impose hazards to exposure. Ito yung tatawag nating anthropogenic fire or yung tatawag nating urban fire, no, yung nangyayari sa building and mga cities natin. Tatawag yan na urban fire or tatawag nating anthropogenic fire. At meron din tayo tatawag na allogenic fire. When we are speaking of allogenic fire, ito yung forest fire natin. Ito tatawag natin sa wildfire. So let us start discussing both. So unahin natin yung urban fire, yung fires nangyayari sa mga houses and buildings or sa urban area. So sa ating urban fire, meron siyang 4 stages. We have what we call as the incipient stage. Meron tayong tatawag na growth stage, fully developed, and decay. So let us start with incipient. So dito sa incipient, this is the beginning stage. This is actually the initial stage kung saan at this point hindi nyo pa kailangan tumawag ng bumbero. No, kasi at this point kaya nyo patayin yung apoy mag-isa. It's still controllable as long as meron kayong mga firefighting equipment such as fire extinguisher. So usually pag nandito kayo sa incipient stage, visible pa yung area kasi hindi pa masyadong makapal yung convection smoke. And due to the fact na hindi pa masyadong makapal yung convection smoke, the area is still visible at this point. So incipient fire pa lang siya. So usually it is characterized by small and it is characterized by small fires. So hindi pa siya widespread. It also allows visibility across the room. No, hindi pa masyadong makapal ng convection smoke and mababa pa yung heat energy na ini-emit ng flame. So that would be the incipient stage. Now, the second stage should be what we call as growth stage. And dito sa growth stage, naumpisahan na maapektuhan ng fire yung ating mga fuel. So once na naumpisa ng maapektuhan ng fire yung fuel natin, darating tayo sa point na nandun na tayo sa growth stage. Mag-umpisa na lumaki yung fire natin. No? So usually during the growth phase, these are the different things that we can observe. First, sufficient yung oxygen to continue the flame. So meaning hindi na siya basta-basta mapapatay ng fire extinguisher kasi sufficient enough yung oxygen to cause continuous flame. Tapos meron na rin tayong layers. Kitang-kita niyo na yung layers above the smoke. No? You can now see the layers above the smoke at this point. no? Then also the room temperature is already increasing by this time kasi nagkakaroon tayo ng mga iba't ibang transfer mechanisms such as conduction, let us say, sa walls, and nagkakaroon na tayo ng faster rate of convection and heat energy. Tapos na-stain na ng brown sa mga glasses natin and nag-start na mag-crack yung window. Darating yung point during the growth stage bago tayo magkaroon ng full fire, darating yung point na mag-i-ignite na lahat ng fuel, no? Fuel sa room, yung makikita nyo nag-ignite na siya, nag-flash over na siya. May makikita kayong light na nag-strike out of the fuel, no? So kunyari may papel sa kwarto, pag nag-start na siya mag-spark, no? Meaning nabot na yung flash over. So darating dito yung flash over point ng lahat ng fuel during the growth stage. And pag dumating na yung point na yun, meaning malapit na lahat ng combustible material umabot na sa point na nag-ignite na sila, umabot na yung point na nagkaroon na natatawag na yung flash over, no? Nagkaroon na ng flash over na tinatawag. Ito yung point na meaning malapit na ma-fully develop yung fire natin kasi nag-ignite na lahat ng fuel possible present in an area. And plus pag nag-umpisa nang masunog, no? Mag-burn yung mga yung mga fuel natin in an area, masasabi natin na fully developed na yung fire. It's usually 700 to 1,200 degrees Celsius. Medyo napaka-dangerous na in terms of temperature. So ito yung mga signs niya, black smoke, no? Dense smoke, very mataas ang temperature, substantial yung heat, black na yung window glazing, hindi mo na nakikita yung exterior, no? And also, di mo na nakikita yung area due to very thick smoke. Tapos, kitang-kita mo yung exterior flame na tatawag, no? Meron tayong exterior flame at hindi mo na nakikita yung smoke. It is being engulfed by the flames already at this point. Wala na kayong makikitang smoke. Di ba remember that in the growth stage, meron pa kayong nakikitang smoke, no? Especially on the upper layer. Dito, it obscured na yung smoke natin ng flame natin. So, meaning sobrang developed na dito ng fire natin. And last, of course, we will have the decay stage, no? Kung saan nag-glow na lang yung fuel natin. And nangyari to, if there is diminished oxygen supply already. Ayan, no? We have the incipient, yung ignition pa lang. Ayan. Thin pa yung smoke, no? And small yung fire. Then, pag kumalat na yung fire, nag-start na yung flash over na tawag, most of the material, no, starting to ignite. Makikita rin natin distinction between the upper smoke, no? Upper smoke layer. So, nandito tayo sa growth stage. Once na hindi natin nakikita yung smoke, meaning fully developed na yung fire at this point, and yun nga, it would end in decay. Sige nga, let's try to identify the stages of house fire. So, let me show you a video, no, that can demonstrate, no, in different stages ng house fire for a while.
Sir, ano nga yung una?
Incipient or ignition.
Incipients, growth,
Incipient,
fully
growth.
developed, decay.
Decay.
Role and importance of students in society. Man belongs to a society. And really belongs to a society. The students are important. Okay? Students cannot even...
Sige nga, try na identify.
Even as school-going students count.
Sige nga, sabihin nyo kung anong stages ng fire yung pinapakita. Sige, start tayo.
Of course, studying is the main occupation of students. But being youthful and energetic, they can engage themselves in various forms of social works in their spare time and movements of crisis such as this pandemic COVID-19. Okay, but the role, the principal role of student is studying, because studying is the main occupation of students.
Okay, anong face yan?
Right? So we have this one.
Sabihin niyo yung face, ha? Sabihin niyo yung face. Anong face to?
Incipient.
Eto, incipient. Correct. Eto.
Growth,
Ayan,
develop.
growth na yan. Kasi nakikita niyo na yung upper smoke layer. Ayan, no? May upper smoke layer na siya. Ayan, growth pa rin yan. Wala pang flash over. Hindi ko pa nakikita yung flash over. Hindi pa nag-i-ignite eh. Hindi nakikita yung flash, ay, nag-skip sa, ito, fully developed, wala ka na nakikitang smoke. Ayan, no? There's no smoke na at this point. Hindi mo na nakikita. Although may smoke, but you cannot see it. So meaning fully developed siya at that point.
Of course, this one brother leadership, kaya
Siguro maganda kung makita natin yung flash over. Sige, mag-search tayo ng video na with flash over para ma-imagine yung sinasabi kong may flash over during the growth phase. O saan mag-start na mag-ignite lahat ng fuel natin. Ayan. We have here a flash over demonstration. Medyo bilisan na yan. Ngayon, kaya baka hindi makita. Sige, let's try again to identify the stages of house fire. Anong stage yan? Okay, incipient. Magsalita naman yung iba, puro si David lang yung sasalita. Sabihin nyo kung pag nag-start na yung growth para alam nyo.
Politicians, they're going to sort campaign for patriotism, double cause and development, student secure, harmony and peace of the nation. In different ways, the student can fulfill social responsibilities. Of course, this one start from preserving, be a volunteer, contribute to make a real difference, condone any form of bullying, follow ethics class, and we will be discussing social
Anong stage? Sabihin niyo pag nag-start na yung growth,
we have this one different places. I'm sorry for this one. Social relationship is an ethical standard. We are discussing social network.
Ayan, anong stage na yan? Nag-growth na ba? Can we say nag-growth na to? Or incipient pa rin?
Social relationship is
Kasi meron ng may smoke na, correct. There's a smoke on the upper layer.
It's what we mean about social relationship. Okay? We have the application not only for ourselves, not only for the persons around us, but also for the benefit.
Ayan, nakikita, may smoke na. Tayo natin flash over.
Every individual has to perform so as to maintain balance between systems. And we have this one, the social network. It's a platform which people use to build social networks or social relationships with other people who share similar personal or career interests, activities, platforms, or real life connections. Right? The social network is to be analyzed. Social map is a visualized, of course, analysis of the digital identity of a person, following a trend of acceptable norms and standards.
Wala pa bang flash over? Hindi ko nakikita yung flash over. Dapat siya
social relationship ties people to each other, social network. Everyone, of course, you also this one. We are interconnected for each other.
Grabe.
Right? We learn, adapt, and quality of life, coherence, sense of personal
Ayan.
health,
Yan yung, oo. Dapat to may flash over tayo. Hindi, wait lang. Hindi ko nakita yung flash over.
Right? And we work closely and develop connections.
Dapat makikita niya mag-sparks yung mga fear play.
Roles in our societies.
Hindi na makita yung flash over.
Families.
Sige, hanap tayo ng video na makita yung flash over.
Associated with gender, sexuality, and race in social. Okay, that's what we call social network. Okay, and we say social network.
Wala siyang flash over dito eh. I did not see the flash over here. Hindi siya apparent. Check nga na.
That's why it uses here collaborate with each other. Collaborate with each other. We work closely and develop connections with their applications and tools. And rules in our society versus very affected by our tools.
Ito yung flashover point, na. Nag-start na yung mga materials to ignite, yung fuels to ignite. Although hindi siya ganun ka-apparent, siguro may mga videos kayo may encounter na makita niyo talaga na biglang mag-flash over, biglang mag-i-spark lahat ng gamit. Ayun, medyo mabilis kasi yung flash over, kaya hindi obvious. So, yun yung total natin flash over. And it's between the growth and the fully developed stage.
The self, others, social web, and then we discuss schools of thoughts also, the appraisal, right?
So, yun yung four phases ng fire natin. And, ano?
And then we also discuss the phases.
Ano ba yung mga possible, natin, no? Possible fire natin, no? Pwedeng it's due to liquid fire, no? Tulad ng mga, mga gas tanks natin. The vaporization of the liquid fuels, no? Would cause liquid fires, no? May mga electrical fire din tayong tinatawag, metal fire, and hostile fire event. So anyways, no, what do we need to understand is meron tayong meron tayong apat na klase ng fire. So meron tayong fires caused by combustible. So class A yan. So it's due to ordinary combustibles such as wood, paper, cloth, rubber, and plastic. Meron din naman tayong class B fire. Pag class B fire, so ito yon, it's due to flammable liquid, yung mga gas natin, yung mga propane, yung mga butane yan. And, class B fire yan. Meron tayong class C fire, meaning it's due to electrical current. So it's due to the overheating of electrical wire. Meron din naman tayong class D fire, which is metal fire. So chemical reaction ng aluminum, magnesium, sodium, or any metallic fire that cause the burning event. At meron din tayong class K fire, meaning it's a kitchen fire. So ito yung common natin. Ito yung mga common causes of fire natin. At yung classes niya, we have A, B, C, D, and K. So pag A, it's ordinary combustible. Pag B, it's due to flammable. So liquid fire to. Pag C, electrical current ang cause niya o yung overheating ng electrical wire, electrical fire siya. Pag D naman is metal fire, it's due to chemical reaction. At pag K, it's due to a kitchen fire. And plus, tatandaan ninyo, nakadepende sa class ng fire, yung fire extinguisher na gagamitin natin. No, it would depend on the class of fire. So, ayan. So, ito yung mga type of fire. Ito yung mga causes, bakit tayo nagkaka-fire, no? Sila yung mga fuels in this case. At ito, yung mga ginagamit natin extinguisher. So, for class A, if it is due to common combustibles, ang gagamitin nyo is water type, foam type, halon type, multi-purpose, dry chemical type extinguisher. Pag class B naman, pag due to flammable liquid, medyo mas mahirap medyo mas mahirap patayin to kasi vaporized yung fuel natin at this point, no? Ang pwede niyong gamitin extinguisher would be carbon dioxide, dry chemical foam, multi-purpose dry chemical, water fog, and halon. Pag class C naman, it's due to electrical overheating. So, kailangan niyo gamitin is multi-purpose dry chemical, carbon dioxide, and halon. Kung napapansin niyo sa class C fire, hindi kayo pwedeng gumamit ng wet extinguisher. You cannot use wet extinguisher kasi electrical wire yan. If you use water, pwede mag-cause yun ng electrocution. That's why in class C fire, usually dry extinguisher ang ginagamit natin. Pag burning metal, meaning yung chemical reaction, no? May mga special extinguisher para dyan, and if it is due to kitchen fire, such as yung nag-burn due to vegetable or animal oil, yung tayong mga potassium acetate solution, no? And this is due to the fact na edible yung mga gamit sa kitchen, and as much as possible, we avoid poisoning in the kitchen. No? That's why meron tayong mga specialized extinguisher for kitchen fire. So meaning class, tatandaan ninyo, titignan nyo muna ano ang fuel for a fire before deciding what kind of extinguisher are you going to use. You cannot just use any fire extinguisher. You should determine the fuel or the cause of fire before using any extinguisher for an urban fire. So I think we're done with urban or anthropogenic fire. Did you understand anthropogenic fire, grade 12? Naintindihan?
Yes po.
Okay, now let us go to wildfires, yung tatawag nating allogenic fire. So dito sa allogenic fire, there are three things that we must consider when we are considering allogenic or wildfire. So we must consider syempre fuel, no? Yung fuel, yung topography, and yung weather natin. Now, why do we consider weather? No? Bakit natin kino-consider yung weather? Kasi yung weather can affect the fuel, no? Pwede niyang maapektuhan yung fuel, no? It can affect the fuel moisture, fuel density. At tatandaan niyo pag mas moist yung fuel, mas less yung mas less yung capacity nun to form fire or to have ignition. And pag lesser naman yung moisture, mas greater yung ability niya to cause fire. So we also need to consider topography kasi it would determine paano mag-spread out, no? Paano mag-spread out yung wildfire natin. Remember that this is wildfire. Hindi siya delimited. Hindi katulad sa urban fire na delimited sa area kasi nga may mga bahay, may mga barriers. Dito sa wildfire, it spreads, no, in a wide space. And dahil doon, kailangan natin i-consider topography and to understand how this fire will be distributed along space. No? Kailangan natin maintindihan yan. So let us begin, no, with paano ba nangyayari yung fire, no, sa ating sa ating paano nangyayari yung wildfire sa ating environment. So of course, it's usual formation of fire or burning event. So mag-start tayo with heating. Kailangan natin mag-start with heating, yung heating ng fuel natin until it reach na ignition point. No? Once na-reach yung ignition point, mag-start na mag-form yung fire. So nagkakaroon na tayo ng flaming. And during the flaming stage, nadi-disperse yung flame natin or nadi-disperse yung fire natin. And at the end, no, it would decay and darating yung point na it will be at its glowing stage. So sa wildfire natin, una, it's just preheating, no, yung pag-transfer natin ng heat energy din sa mga fuel natin to cause ignition, followed by flaming, the formation of fire na, and the spread of fire, of course. And the last stage would be glowing, kung saan nag-decay na dito yung fire at this stage. So these are the three stages of combustion in your wildfire. At possible yun if there is a mode of heat transfer, can be in the form of convection, no? So pwede tayong mag-ignite ng fuel natin. Marami kasing fuel sa wildfire. Marami kasing possible fuel for wildfire or marami kasing sources ng fuel sa ating forest that can cause wildfire, no? And what do we need to do is to transfer heat energy to this fuel. And tulad ng normal burning event, no, it can be transferred by convection. So yung convection smoke natin, it can be transmitted or dispersed all throughout the area. And upon dispersion, no, pwede siya mag-transfer ng heat energy that would cause the ignition of the fuel present in your forest, so let us say. So pwede rin by conduction through the lupa, no? Yung lupa, it can conduct actually heat energy, no, that would cause the increase in temperature and the ignition of the fuel, and it would also be caused by your radiation, kung saan nagra-radiate tayo ng heat energy to the fuel, and this radiation can cause the pyrochemicals, no, of the different pyrochemicals of the different plants to ignite, or yung fuels natin to ignite. So it's just regular heat transfer, no, yun nga lang in the context of your forest, no. We're speaking here of forest. Now since we already understand how does combustion happen in your forest at paano nata-transfer heat energy, so pansin niyo the combustion event is the same. So, kailangan na ignition, no, by heating, flaming, then decay. And yung heating na yun, it would be due to transfer of heat by three processes: conduction, convection, and radiation. Ngayon, let us examine naman yung mga fuel natin. So tatandaan ninyo, ang wildfire, nakadepend siya sa fuel also. It would depend on the quantity of fuel, how much fuel is present, anong type yung fuel na present, no? And sabi ko nga sa inyo, in forest, no, or in the environment, no, napakaraming fuel dyan. There are many fuel available there to cause fire. Ano yung size ng fire natin and the arrangement, no, ng material. Later on, makikita nyo na sa forest pala, pwedeng yung material naka-arrange siya horizontally or vertically. And doon natin ma-describe yung spatial pattern ng fire during a wildfire, kung horizontal fire siya or vertical fire. Also, yung distribution ng fuel across the area and yung moisture. Kasi yung moisture, malaki yung contribution yan sa formation ng wildfire. The less moisture, the greater the wildfire. So kaya nga pag El Nino yung event, lalo sa Australia, pag nakaka-experience ng El Nino, mas prone sila sa wildfire kasi mas less yung moisture sa mga fuel doon. Unlike ng regular days or La Nina na great yung moisture, mas less yung wildfire scenario natin. Ayan, so let us describe first ano yung mga type ng fuel. Sa wildfire natin or sa forest natin, ang mga fuel natin, it could be a surface fuel. So ito tawag dito surface fuel. So pag sinabi yung surface fuel, nasa surface siya. Pwede siyang subsurface, nasa ilalim ng lupa. Kasi yung fire natin sa wildfire, pwede siyang mag-penetrate sa ilalim, no? Kasi may mga fuel rin na present sa ilalim, no? So pag hinukay niyo yung lupa after a wildfire, makikita niyo burnt din yung ilalim niya, meaning there is a depth of penetration of wildfire underneath. And pwede rin nasa crown yung fuel natin. Andito yung source of fire natin along the crown. So yan. So pag surface, no? So meaning yung combustible material yan na nasa ground, no? Or yung tinatawag natin na nasa surface, no? Nasa surface, nasa above ng duff layer. Tawag dito class is duff layer. We call this as duff layer at ito crown layer. So pag nasa taas siya ng duff layer na tinatawag natin, tawag sa kanya is surface fuel. Meron din tayong tatawag na subsurface fuel. Ito yun. Ito yung nasa ilalim ng duff layer. Fuel nasa ilalim ng duff layer. At pag yung fuel naman nasa taas, no, this is the crown fuel. So anyway, this is ladder fuel. This ladder fuel can help the flame to climb up sa crown nyo, no? Or kaya siya tatawag na ladder fuel because it can help transfer flame or even transfer heat energy from your surface to your crown. Kaya siya tinatawag na ladder fuel. So ayan, anyways, yung fuel natin, no, it can vary, no, from species to species. May mga plant species tayo na mas greater yung ability mag-cause ng combustion. And may mga species naman tayo na mas great yung ability to cause combustion. Tapos iba-iba rin yung size ng fuel natin, nakadepende rin siya sa arrangement and how it is distributed. So meron tayong mga fine fuel. So yung mga fine fuel, sila yung madaling mag-ignite. Usually mga maliliit to and spread. They are spread or widely distributed all throughout the surface. So example nito yung mga grass, fallen needles, leaves, and small twigs. So mga fine fuels to. May mga medium fuels tayo, medyo mahirap sila i-ignite. No? It is a little bit harder to ignite at meron tayong mga coarse fuel and usually napakahirap na i-ignite. Pero once na na-ignite sila, napakahirap din na i-stop. Ito yung fuel arrangement na sinasabi ko. So ito, tong tawag sa fuel arrangement na to, this is a ladderized arrangement, no? So ladderized arrangement, ito is slash. So pag slash usually mas mataas yung intensity ng fire nito. Pag slash yung slash yung slash yung arrangement niya. Ito naman pag ladder, hindi intensity ang naapektuhan. Ang naapektuhan nito yung rate. Kasi pag ladder yung arrangement, there is a widespread wildfire or mas mabilis mag-spread yung wildfire. No? So ayan, tulad nga nasasabi ko, pag laddered yung fuel, mabilis mag-spread yung wildfire. Pag slash naman yung fuel, there is a greater intensity of wildfire natin kasi greater surface area of the fuel is exposed on the ground, no, causing the intensity of the wildfire to be greater. Sometimes may barrier, no, distribution niya, there is a barrier in between. Yun nga lang, sometimes pwede pa rin niya maabot by radiation or by convection. So possible pa rin mag-ignite yan. Pero that would be slower. That would be at a slower speed, sorry, slower pace due to the presence of a barrier. Ayan, yung fire natin, it could be a ground fire, it could be a surface fire, or it could be a subsurface fire. Now, so when we are speaking of fire or flame, so we will expect the following, no? Meron tayong flame, no? Of course, and in flame, we must consider flame length. Lalo na pinag-uusapan natin is wildfire, no? We must consider the flame length, yung flame height, this is flame length, flame height, and flame depth. And talagang sabi ko yung depth, usually nagpe-penetrate kasi yung fire natin in wildfire. So makikita nyo underneath the ground, no, there is an extension of tar, no, or there is an extension of fire underneath the ground. So it expresses the flame depth na tinatawag natin. And yun nga, in wildfire, nakadepende yung mitigation niya sa flame length, flame height, and ano, flame length, flame height, and flame depth. Usually, pag 1 meters na yung yung flame length, pwedeng lumapit yung firefighter. Pero if it's greater than 1.4 meters, ang mga firefighters natin, they cannot go near the wildfire. Kailangan muna nilang babain yung intensity ng wildfire before mitigating the event. For a while, may i-chat lang ako. Saglit lang. Thank you. Okay, so let us continue where we have stopped. Sorry for the interruption. I have to chat someone. So now in wildfire, we must consider no the morphology of wildfire. So sa wildfire natin, meron tayong tinatawag na na head. So yung head siya yung proceeding part, no? Siya yung nasa unahan ng fire, ng wildfire natin. Then we have the flanks or the sides na tinatawag. And here, class, if you would observe, may mga depressions tayo. And these depressions are called bay. Then we have the fingers here. Tawag. At yung mga separated or isolated flames natin, tatawagin yun na spot. So we have the head, the proceeding area, the flank, the sides. Ito, bay tawag dito. And yung discordant fire natin would be your fingers, no? Then, tong mga isolated is a spot and tong buong area that is affected by the wildfire, tinatawag yan na fire perimeter. So, ngayon, no, sabi ko nga sa inyo, may effect yung weather natin sa wildfires natin. So, there are things that we need to consider now when we are speaking of weather. So we need to consider humidity, precipitation, temperature, and yung wind. Anyways, class, wala, mag-asynchronous lang si Ma'am Flores ngayon. She is giving her time to finish all the asynchronous activity and for you to make your proposal defense. So, say thank you lang later kay Ma'am Flores. So, ulitin ko, so these are the different factors that we need to consider for for in terms of weather at paano niya naapektuhan yung wildfire natin. So first yung relative humidity, no, and precipitation. So yung dalawang yan, yung relative humidity and precipitation, obviously it tells you the water content of the fuel. So pag mas mataas ang relative humidity at precipitation, obviously mas mababa yung ability to cause ignition kasi mataas yung humidity. Pag mababa yung humidity naman at mababa yung precipitation, obviously mas mataas yung ability to cause ignition kasi mas dry yung fuel natin at this point. In terms naman of temperature, of course, temperature has an effect, no? Pag mas mataas yung temperature, mas mabilis magkaroon ng ignition. Pag lower yung temperature, mas less yung capacity to cause ignition. Kaya nga pag El Nino, ulitin ko sa Australia, no? Kasi this is very common in Australia. This is a very common disaster in Australia. Sa Australia, no, pag El Nino, very common ang wildfire kasi nga napakataas ng temperatures at napaka-dry no ng atmosphere nila during that time. And because of this, there is a greater chance of ignition of fuels at this point. And also yung wind kasi it would dictate kung paano mag-spread yung wildfire natin. That's why we need to consider also yung wind. Now, another thing that we need to look is yung topography. Kasi yung topography yung mag-determine ng distribution ng wildfire natin. So for example, we have this topography. Meron tayo ditong topography. So obviously, if you would observe here saan, paano kaya magiging direction ng fire natin? Where do you think ang mas mataas yung rate ng spread ng wildfire? Is it in the northern or the southern side of this topography? Anyone?
Sa North, sir.
Obviously sa north kasi greater yung density ng fuel and obviously ladderized yung arrangement, mas mabilis ang spread ng fire natin. Yung wind, 'di ba? Tulad ng sabi ko, yung wind also would affect the distribution and the spread of wildfire. And saan mas grabe yung effect? Tignan nyo, if you have a plain, no? Kung plain yung lupa nyo, yung distribution ng wind hindi masyadong profound yung effect. Pero if you observe this one, kung sloping yung ating topography, yung spread would be a little bit faster kasi yung convection column mas madali niyang matatransfer yung heat energy pataas if sloping yung topography natin. No, so there is an easy transfer of heat energy by convection at this point. No, if you have a sloping topography, ayan. The flame will be closer to fuel. The convection smoke will easily transport the heat energy to the fuel at this point. Ayan. Mas madaling matatransport. Isipin nyo, sloping, tas may air tayo. And remember that your wind would blow parallel to your lupa. So, mas madaling matatransfer heat energy by convection smoke at this point. So ngayon, may effect din yung physical barrier. So ito, with this physical barrier, kunyari we have a physical barrier here. So makikita natin yung wind, no? It is transported parallel to the ground here in the windward side of the barrier. Pero sa leeward side, it will be turbulent. So we would expect here na mabilis yung spread ng fire sa windward side, pero intensity ng fire will be greater sa leeward side kasi naging turbulent yung wind speed natin at the leeward side. Kaya sa one effect ng barrier is that widespread sa windward side, intense yung sa leeward side. Dito naman, due to channeling, kunyari, meron tayong channel sa gitna, ayan, this is a channel in the middle, we will expect na pag-enter sa channel, magbabago yung direction ng wind natin, and yung wind natin magpa-follow ng direction ng waters. So this can determine how will the fire spread all throughout the topography. Meron din tayong tatawag na funneling. So, kunyari may saddleback area kayo. So, this is an example of a saddleback area. So, nangyayari pagdaan ng wind nyo dito sa leeward side, magiging turbulent siya. And if that's the case, magiging intense yung fire at this point. So, tawag dyan sa event na is funneling. So, ito, we have channeling, no? Dinedetermine ng direction ng lupa, yung direction ng fire, at direction ng tubig, no? At yung presence ng barrier. So, dito, tignan nyo, it followed the direction ng lupa, direction ng water, pero pagdating dito sa channel, mag-change ng direction. So, that would help you determine the direction of wildfire sa channeling. Sa funneling naman, it can help you determine no, ano yung magiging changes dun sa dynamics ng fire natin. And in this case, no, yung naging turbulent siya after passing in the middle, no, we would expect na greater yung intensity ng fire natin. Ayan, so this is an example kung saan saddleback siya. So we would expect pag cross dito, magkakaroon ng intensive fire. Ito channeling naman to. Yan, magbabago yung direction. Ayun, there is a change in the direction of the wind, thus mag-change yung direction ng fire natin. Ito, this is funneling. Okay, another thing that we need to consider is ito, yung effect ng what do we call this, ng higher temperatures, no? So for example, mainit ngayong araw na to. Pag mainit ngayong araw, syempre, mas mainit yung air sa surface, no? And because of that warm air, no, natatrap siya under the cool air. Remember na mas dense yung cool air kaysa sa warm air. So dapat ang tendency, lulubog si cool air over warm air, no? Ang nangyayari dito in this case, no, dahil nga masyadong warm yung air sa baba during that point. So, nangyayari, pag nagkaroon dyan ng ignition at nagkaroon ng flame dyan, mangyayari yung warm air na yun would move the flame towards the cool air. Kasi mas mataas yung density ng cool air, magsisink siya, si warm air, magra-rise siya. And the rise of warm air cause the vertical distribution of fire across your wildfire. Kaya minsan, pataas yung fire kasi another thing that can happen is that no, magmo-move up yung warm air pataas, then magmo-move down yung cold air pababa, causing the distribution of fire vertically. Aangat yung tinatawag natin wildfire. And we call this as an upslope wind event, no? I mean, nangyayari to kung meron tayong upslope wind event kung saan umaangat yung fire natin due to the movement of wind upwards, no? Due to difference in density. So, yan yung mga possible effects na ating elevation. So, ayan, no? I think na-discuss ko naman to sa inyo. So ngayon, ano yung fire behavior in a wildfire? Ano yung mga ma-observe nating fire behavior? So meron tayo class tinatawag na creeping. Pag sinabi yung creeping, this is a very slow fire. Napakabagal ng fire na to. This is a very slow fire when we say creeping. Pag smoldering naman, usually wala tayong flame. Walang flame to. There is no flame. Pag running naman, kabaliktaran ng creeping, is a very fast wildfire. Pwede rin naman torching. Pag torching, vertical yung pag-distribute ng flame natin. Pag crowning naman, sa crown nag-spread out yung fire natin. And pag spotting, meron tayong mga embers na tinatawag, yung mga nagbo-burst na fire. Yung tatawag na embers. Na-observe nyo to pag gagawa kayo ng charcoal, di ba may mga embers na tumatalansik. So spotting ang tawag doon. And that embers class can initiate spotting, no? Mga spot flames na tatawag or isolated fires due to ember distribution during the burning event or combustion event. So yan, so alam niyo naman na maraming effects ng wildfire. May effect siya sa biodiversity, may effect siya, yan. May effect rin siya sa exposure, pwedeng maraming madamage, agriculture, no? Pwedeng magkaroon tayo ng problema rin sa residential problem, pwedeng maapekto yung mga exposures. So marami siyang harmful effect. Pero take note that wildfires also has many many good effects, many beneficial effects. Kasi class, this is an ecosystem service. This is a service provided by the ecosystem so that magkakaroon tayo ng succession in our forest. And when we say succession, ito yung process sa forest natin kung saan napapalitan yung previous species natin ng panibagong species. That shows the maturity of the biome itself. Kasi part yun, it's a natural cycle of an ecosystem to replace its keystone species, ang tawag doon, to replace the keystone species with new species that can produce a greater biodiversity. And that's why meron tayong wildfire. It's actually part of your succession na tinatawag natin. And that's, I think, the last thing that I need to discuss about wildfires. Okay, before we end,